Alright, for this lesson we're going to talk about the algebra of functions, and all that means is that we're going to take regular old functions like f of x and g of x and any other functions we may have, and we are going to perform basic operations on those like addition, subtraction, multiplication, and division. And we're going to look at how the functions are going to be combined. Alright, so first of all, let's talk about what a function is, if you haven't remembered that already. A function is like f of x. This is function notation, and we have lots of different types of functions. We can have linear functions like the ones we've been studying the last couple of weeks. We can have quadratic functions or square root functions, or pretty much any other type of function that you can think of that you've already studied. You're going to probably see. Probably would be a good idea to make a list, so let's try that real quick. I've already got linear and quadratic. Those are the two that you are familiar with. Alright, so linear is like with an x variable, and quadratic is with an x squared. You could have a cubic, which is obviously x cubed. You can have an absolute value function. You can have a square root function. What else have we studied? You can have a rational function. Okay, I'm kind of making my list backwards here. Let's put these over here. Okay, let's go ahead and name these. What did I say? I said absolute value. Let's abbreviate that. Square root function. You can have a cubed root function or any other root function. We have a rational function. And that's probably a pretty good list to start with. You may see one or two more, but they all work the same. Okay, so when we're talking about the algebra of functions, we're talking about how we deal with the process of adding these things together, or maybe subtracting these things. And you have to remember that with addition and subtraction, you are looking for like terms, right? Like terms are those terms where the variable is the same as well as the exponent is the same. So in this instance, with my two functions that I've already listed here in blue, the only like terms that we have are these at the edge, the positive 1 and the negative 4, because those are constant terms. This x term has a squared and this one doesn't, so they're not alike. And if I tried to add these functions together, the result would be 1x squared plus 3x, and then I can combine those and get negative 3. Okay? So when you're adding or subtracting, you're combining like terms. When you're multiplying, okay, it's not about like terms, it's about if you're multiplying these together, you would have to use the FOIL method. Right? You might not have heard of that for a while. FOIL method is where you distribute and you multiply every term of the first by every term of the second. Okay, so you'll have 4 parts here, and this would be 3x times x squared, so that would be 3x cubed. Remember the exponents increase there. 3x times negative 4 is negative 12x. The 1 times the x squared is 1x squared. You have the 1 times the negative 4, which is negative 4. And then normally what we would do is go ahead and write it in descending order, and maybe combining any like terms that we have as a result. And I don't see any like terms, so we're just going to go ahead and write it in descending order. The exponents are getting smaller from left to right. Okay? There's a few other things we'll take a look at, but let's get into some real examples here. Okay? So listed at the top, I have two functions. I've got f of x and g of x. And this first part tells us that we want to find the value at 2 for the sum of f and g. Okay? So what we can do is we can calculate f of 2 and g of 2. And let's see what that would be. That would be f of 2 would be 14. G of 2 would be, I believe, 4, if you plug in the 2 there. And so if we were to add those together, you would get a value of 16. All right? Pretty simple when you're evaluating them. Let's try another one. F times g of 0. So let's see what this is. F of 0 is 0. G of 0 is negative 2. And the product would be the 0 times the negative 2, which is still 0. All right, let's try another one here. This one at the bottom says f divided by g of 2/3. So let's find each of those. So f of 2/3 would be 14/3. G of 2/3 would be, well, let's see, I'm going to go ahead and write this one out. 3 times 2/3 minus 2, so that's 2 minus 2, which is 0. And so what they want us to do is divide these out. 14/3 divided by 0, and that is undefined, right? We can't divide by 0, so there is no solution to this problem. Okay, let's see if I got another one down there. Nope. All right, so that's pretty easy when we have a number that we're going to evaluate a function for. You could just plug into each function and take the resulting values and perform the operation. Okay, so this next set of examples is with the functions, two new functions, and we're not evaluating them. Right? There's no number. It's not f of x or f plus g of a number, right? It's just the sum of that. Okay, so let's see what we get here. We want to add them up. There's nothing to plug in, so I'm just going to take the functions as they are and try to add them together. So what are the like terms? Well, I've got the x squared, and that's the only one of its kind here. I've got the x, and that's the only one of its kind. But the positive 2 and the negative 4 I can combine together. And so this is the sum of the functions. All right, let's try the difference. Let's do x plus 2 and then minus x squared minus 4. Right? Same thing here with the common like terms. If we have them, we can put them together. And you may want to actually distribute, think about that, distributing this negative 1, so to speak, through the parentheses. All right? So this is going to give me a negative x squared. Right, that's the only one of its kind. I still have my positive x, and then I have 2 and minus a negative 4. 2 minus negative 4, that is a double negative, so that's going to be 6 this time. All right, and the third one here is the product, so we are going to FOIL it out. All right, so I wrote them down there. Let's scroll my page. And what do we get when we FOIL them out? We are going to multiply the first term times both of those in the other, and then the second term times both of those in the other. The result, I'll go ahead and write it to the side here, is going to be x times x squared, which is x cubed. Then we have x times negative 4, which is negative 4x. Then we're going to do 2 times x squared, which is 2x squared. And then we'll do 2 times negative 4, which is negative 8. And now in descending order, we'll have x cubed plus 2x squared minus 4x minus 8. And there are no other like terms that we could put together. All right. Last one here for these two functions, we want to divide them. And since we're not plugging in a number, we're just going to write our function f on top and our function g on bottom. And that's, well, at this point, you could try to simplify these fractions. Maybe, I hope you realize that the denominator can be factored. Maybe you do, maybe you don't. It's been a while, so I'm not expecting this of you. But if you notice the bottom is a difference of 2 squares, you can factor the bottom part as x plus 2x minus 2. And then, with those factors, you can see that there is a common factor between the top and the bottom. So you can go ahead and cancel those out. and then this is what's remaining. Okay? You will have to list excluded values from the original part here, right? We don't want to divide by 0, so these are the values that we're not allowed to use. We're not allowed to use positive 2 or negative 2, because if we plug a positive 2 or a negative 2 into the original function here that we created, we would end up dividing by 0, and that's not good. Okay? So those things right here, they need to be written, and they are called excluded values. Excluded values. All right? If we don't exclude those, then we're going to have the same problem that we had on this other example where we ended up with something that wasn't defined. So make sure you list the excluded values there. All right, so here we have some functions that you haven't seen in a while. The first one there, f of x, is an absolute value function. The second one is a square root function. And let's see what happens when we do the algebra on those. So this first one wants us to add them together. So let's go ahead and write it. The f function and the g function. And then we want to combine all of our like terms, which there aren't any. Absolute values cannot be combined with the square roots and vice versa. So we're just going to have to leave it like that. All right, and that's okay. That's okay, just leave it like that. And then when we try to subtract them, well, we still don't have any like terms, so we can't subtract them. We just have to leave it like that. Now that may make some of you feel uncomfortable, but think about it. We're not going to have to do any work here, okay? So just leave it like that. All right, going on to the third one. They want us to multiply these. So let's see what we can do. We're going to do 2 absolute value of x, and then multiply that times the square root function. And this isn't like the last couple of examples where we had a binomial times a binomial and we used the FOIL method. This is one term and this is one term. It's one square root. And when we multiply them together, really all I need to do is drop the parentheses, because it's just 2 absolute value of x times the square root of 1 minus 2x. Again, nothing really we need to do there. All right? And then the last one wants us to divide the two functions. Make sure you know which function goes on top. Sometimes they switch them around, put g divided by x, or g divided by f. So let's see what we get here. We're going to have the absolute value function on top, and the square root function on bottom. And I can't factor any of these, so there's no canceling of factors. All I need to do now is list my excluded values. What value for x am I not allowed to use? Right? We don't want to divide by 0. And of course we can't take the square root of anything negative. So we have to go over to the side here and we have to think about this. This part right here that was underneath the radical symbol, it has to be greater than 0. It can't be 0, it can't be equal to 0, because then that's a problem, right? Dividing by 0 is a problem. And it can't be less than 0, because that would be the square root of a negative number. We can't do that either. So we just have to solve this part real quick, and this is why we studied inequalities last week. Let's go ahead and subtract the 1 to the other side. Let's move that over there. That'll give us negative 2x greater than negative 1. And then if we divide both sides by negative 2, what are we supposed to do if we divide by negative here? We are going to flip the direction of the inequality symbol. So our excluded values, or the values in this case that we're only allowed to use, are less than a half. Okay, got to list that out there. All right. Anything else here? Nope, that's all we have for this lesson. Give the homework a shot, and if you need any help, send me an email.